Did you say you're the guy that does the math?
Yeah, I am the only guy that does the math, apparently. Yeah, let's leave it at that. Yes. I have to apologize, friends. You are embarking on a journey. You are well within the journey of statistics that makes you more cognizant of the truth and limitations of data than most of your American colleagues. I welcome you with open arms to that little unit. I also am immediately frustrated for all of you because you're going to deal with most of your American colleagues who don't understand data and refuse to be moved by them. So just realize that. I've had a number of students say, I watch the news now and I get frustrated. Yeah, that's a disease I've now spread to you. And you're going to deal with it the rest of your life, pretty much, if you didn't already. So it's okay because you're better off for it, but acid indigestion sometimes too. Speaking of acid indigestion, speaking of mislabeled statistics, let's back up to the first slide of this bad boy. This is what was told to us on Max's 2-year checkup. So the reason I started this whole thing in particular was because this number. Now, we were told he's in the 80th percentile. We also had his weight at that time. And we said, yeah. And they said, what does he eat? He said, food. What kind of food? And we said, 2-year-old food. Broccoli, he loves broccoli. He likes fish. He likes Cheetos sometimes. And she's like, really, how often does he eat Cheetos? And I'm like, you know what, time out. What are you getting at? And they said, well, any child over the 50th percentile, we want to talk to the parents about obesity. And before I had a chance to open my mouth, my wife chimes in and she said, do you also talk about all the children under 50th percentile for undernourishment? And the health practitioner said, oh yeah. And then my wife, without missing a beat, said, so basically you're warning every single parent they're either over or underfeeding their child. And but that's the thing. They viewed that one number in isolation of the other two. Yeah, he's in the 80th percentile for weight. Guess what he is for length and head girth? My God, 85th percentile for head girth. Most of his weight is right there. That's not Cheetos, right? So that's what I'm talking about. You can hear my voice getting more strained. That's what I'm talking about, the misinterpretation of what this is actually telling you. Viewing that in isolation, here's another one for you. I am marginally overweight by BMI. Every time I calculate my BMI, I am this close to being overweight for my height.
That's all right, I'm obese, so.
Exactly. Marginal, I'm this close. I'm within 2 standard deviations, but just barely. Right? And if you look just at BMI, you're like, rule, diet. And then I say, I'm also 12% body fat. And they're like, wait a minute, how can that be? Well, duh, how they calculate BMI. It's weight and it's height. Those are the only 2 things that go into it. What weighs more? Muscle weighs more than fat. So you got very little fat and more muscle by comparison. I'm not muscle bound by any stretch of the imagination, but I'm denser than the average person with my 25.4 BMI. I just got it back, 25.4, which is like this close for my age group of popping out. Patty, go ahead.
All weightlifters would be overweight, according to the BMI.
How about bike commuters?
They'd all be obese.
Exactly, because we're off the charts because the scale doesn't apply to that condition.
Right.
But how many decisions are based on that? We have a Healthy Futures program at our school where the idea is you do these healthy things and you get to cut off your deductible and your health insurance. One of the things you put in is your BMI. I'm like, time the hell out. Why are we still using this antiquated measure? By itself, it's stupid. You see how my voice is raising and registering. I apologize.
That's the worst thing you could possibly use.
Pretty much, because it ignores every other variable except for your height and your weight, which are not that tightly correlated, unfortunately. Anyway, sorry, set it down. Zen. I wanted to share a few more things with you guys before we got into your data. I want you guys to generate some data for me. I mentioned, Carly, you mentioned something. I think Veronica did too. You guys were mentioning how it would be more helpful to just count up the boys in the chart and figure out what percentage are below a certain weight class. To make that job easier, different kinds of histograms are often used. One's called an ogive, cumulative frequency histogram. If you make it a bar graph, or if you make it a line graph, it's called an ogive. See if you can see how this differs from the original histogram. Same data, but see if you can see how this differs from the original histogram. Take a look at it. Take a look. Look at the frequency the frequency axis too, and look at the label on the frequency axis. What do you notice? What do you notice?
It's at or below instead of below.
Aha! It's at or below. Jolene, go ahead, my friend.
So essentially you're taking the bars and adding it to the next bar.
Perfectly said. If you look at the original histogram, it goes 3, 1, 2, 2, 4. I'm giving the frequencies, right? 3, 1, 2, 2, 4. Weights from 20 to 24 pounds. If we fast forward to the cumulative, this is still 3. This bar is 1 higher because what you've done is you've taken the kids below 21 pounds and added to them the ones at 21 pounds. So that's 3. This is 4 because it's 3 plus 1. This is now 6 because it's the 4 plus the next 2. This is 8 because it's 6 plus the next 2, and you just keep on. The weights are the same. But now, when you look at 22 pounds, you know it's at roughly 6 because there are 6 kids that are at or below that weight. Not just at that weight, but at or below. It saves us the arithmetic. It saves us the, because now if we want to find Max, all we've got to do is find the bar that's 80 high. He's over here because these kids, these 80% of kids are all lower than that 31. For certain applications, this is a godsend. For percentiles, when you actually have to go and look at what's below you. I'm not saying it's always a good idea. This is why I saved it till now. I didn't bother talking about it the first day of class because it didn't make any sense then. But if you need to very quickly figure out the bottom of a data set, notice how it goes to 100? There are 100 kids in the sample at or below 33 pounds. Because the 33-pound kid was the highest kid in the sample. So 100% of the sample is either 33 pounds or less. 99% of the sample is 32 pounds or less. There's just that one kid that was heavier. Is that fair? You guys see what we're getting at there? So I'm not saying this is always useful. I'm saying it's sometimes useful. And this was that first chart we actually referred to. This is the chart they hand you at the doctor's office. Notice the shape. It looks pretty similar to, actually I skipped over a slide. That's what's called an ogive, which is a silly name. I'm not even sure where it comes from. It's basically that graph, but just a line. And this shape, in particular this one right here, you see right there in the pediatrician's growth charts. There's a lot of information on this chart, tons. This is birth through 36 months, so the first 3 years of life. And let's see, Max was at his 2-year checkup, which would be 12 months. So if you scroll up,
24 months.
24 months. Thank you guys for checking my math on that one. Thanks, YouTube world. I got math degrees. 24 months. And then you scroll through. Here are his weight percentiles. And up here are his length percentiles, the way I have the chart set up. So basically, 24, if you scroll through here, this is the 5th percentile for weight. 5th percentile, which would correlate roughly to, it looks like just over 26 pounds, I guess. 10th percentile is just under 28. And if you keep going, you'll find Max in the 80th percentile is the 31 pounds. He's up here somewhere. Somewhere like right about there, which correlates roughly to your 31 pounds. And again, you gotta remember too, when the doctors do this chart, they round the weight off to the nearest pound and then put the dot as close as they can on that chart and then read it to you. Look at how tight. Remember your standard deviation measure, Carly, you mentioned before? I promised you 5 minutes, I'm only 25, I apologize. Look how tight these percentiles are at young ages. You can be off by a couple millimeters on your dot, and that could be 15 percentage points, which might tip you over 50th percentile, give you misleading information. That's why it's good to trend those things. Max, when he was younger, I've been trending his numbers. When he was younger, he was on the heavy end of everything, the high end percentile, length, weight, and head girth. He's starting to level off and become more average as far as size goes. Like he grew into his head, so to speak. I mean, he had this Charlie Brown head for 3-4 years of his life, and now he's finally starting to get tall. And he looks more like, oh, there's my boy, my normally shaped boy. Charlie's. I say normally shaped. Kids with big heads are adorable, we know that. But the idea is you can be very off in here with a pencil point, and as they get bigger, and this chart actually goes out to 20 years. They actually have growth charts up to 20 years, which are very, very interesting. So, yeah, it's pretty crazy. They have them laid up a little bit differently. It's an old piece of paper, which is kind of great. What's on your mind, my friend? Tell me your name, Drew.
Me?
Yeah.
Kendra.
Kendra, you're taking that in.
I was just wondering how you saw
The 31 pounds?
percentile on there.
Oh, so it's these very small numbers right here, which are hard to see. 95, 90, 75, 50, 25, 10, and 5. If the thing was the correct size, it'd be easier to see. And then these are kilograms and pounds. So basically, we knew max was at 31 pounds. So you go to 31, and then you come across until that intersects 24. And they approximated that as the 80th percentile because it's between 75 and 90.
Okay.
That's where the 80 came from,
Okay.
right? Now they also made a little bit of a mistake in the fact that this is not a linear 75 to 90. Like every unit isn't 5 more percentage points. It actually begins to spread out, or actually tighten in, excuse me, as you get towards the end. But I let them slide with that one as long as they're close. I'm not doubting the 80th percentile. I think they did that fine. It's the interpretation of what that means that upset me a little bit. Like my kid's overweight. So, cool, fair. So that's something some of you have dealt with, some of you might do at some point, and some of you can settle your friends down when they get upset if their doctor tells them their kids are overweight with this discussion, which is actually kind of fun too. So now let's collect your own data. We'll come back to this momentarily. Shut this off. Data sheets, again, if you will. Data sheets, if you will. If anybody needs it, I think I have a few more copies.